So at the top of your notes, what you're going to write is this essential question. So you're going to write, what does a Bohr model represent? This is going to be the essential question that you're going to answer when we're all done with our notes, okay? In your summary. So what does a Bohr model represent? Okay, so write this down on your top of your notes, okay? Okay, so we're going to talk about a Bohr model. Remember, a Bohr model is from Niels Bohr. Niels Bohr came after Rutherford. Remember, we had J.J. Thomson who found the electron with his cathode ray tube, that it repelled, right, the negative particles when you put the magnet up to it. And then Rutherford came after with his gold foil experiment, and that's where he found the dense positive center, or the protons. Niels Bohr came after him, and he had the theory, and still holds today, that electrons orbit around the nucleus like we orbit around the sun. We do know now that there's different shapes that they orbit around, but we call it the electron cloud model. And remember, from the periodic table, we can tell how many energy levels are in the electron cloud model. So if you look at the periodic table, when we're deciding energy levels, what number do we look at? What number do we look at when we decide how many energy levels something has? Where do we look? On the side. What are those numbers called on the left side? They're called the period numbers. So the period numbers tells us the energy levels. So how many total energy levels do I have for our elements? Look at the periodic table. How many energy levels are there? 7, because there's 7 periods. So in the electron cloud, we have 7 different energy levels. We will not most likely go over energy level 4, and we'll stay at number 20. No farther than probably number 20, okay, here in this class, okay? All right, so Bohr models are used to show the arrangement of electrons, and electrons are placed in the first shell first. Remember, I told you guys energy levels and shells kind of are used interchangeably. When we talk about Bohr models, we usually talk about the shells, but it's really just the energy levels, same thing, okay, that we read from the period number. And once full, extra electrons are placed in the next shell. So we fill the first energy level, then the second, then the third, kind of like we write our electron configurations, okay? All right. And so the different shells have the maximum number of electrons. So the first energy level, or first shell, can only hold 2 electrons. The second shell can hold 8. The third shell can hold 8. When we get to the fourth and above, we're talking 18 or more, okay? Now, here in this class, I'm not going to take you into when the D's get taken in. We will leave it at the S and the P's, okay? So we will not go over element 20, except in practice. You will practice it, but you will never be tested on it, okay? You will be only tested through element 20 on a Bohr model, but in your practice, you're going to go over 20 just to practice it so you see what it's like. When you get to higher chemistry, they do make you do them. Okay? All right. So the periodic table can help us quickly complete the Bohr model by using our electron configuration, which was what we're going to use. And the number of periods or rows shows you the number of shells. And the number of groups or columns shows you the number of electrons in the outer shell. And those are our valence electrons. We call it the outer shell, or we call it the valence shell, okay? And it can quickly tell us how many are there by a Bohr model, okay? We can also calculate, as we learned, from the electron configuration. Okay? All right, so let's take a look. I want everybody to take out your periodic table. I want you to find phosphorus. Find phosphorus. We're going to model phosphorus here. Find phosphorus. So I want you guys to tell me, how many protons does phosphorus have? 15. How do you know that? It's at the top. It's the atomic number. Remember, atomic number equals the number of protons. We're dealing with neutral atoms. So if it has 15 protons, if it's a neutral atom, how many electrons does it have? 15. Now, the Bohr model models the electrons, which means we should have 15 electrons. So when we fill in our phosphorus here, we're going to have a P for the symbol, right? Atomic number is going to be 15, we just said, which means it has 15 protons and 15 electrons. When we're doing the Bohr model, we are not so worried about the neutrons, okay? Neutrons affect isotopes. In a Bohr model, we're really just focused in on the electrons, okay? All right, so now what I want you guys to do is I want you to write the electron configuration for phosphorus. Right now in your you have a little piece over there to the side, says electron configuration. I want you guys to write not the shorthand, but the full electron. So take a minute and do that now. For phosphorus. Take a minute, write the electron, the full electron configuration for phosphorus. Okay? If you have your electron configuration done, what I want you to do now is take your highlighter and you're going to highlight the valence electrons. Remember, the valence electrons are the ones in the highest energy level. So find in your electron configuration the highest energy level, and then you're going to highlight the exponents that go with that energy level right now. Okay? Okay? All right. For the electron configuration, I'm hoping what you have down. If you don't, you can ask me. We can go through this later together. You should have 1s2, 2s2, 2p6, 3s2, 3p3. Yeah? Okay, what is the highest energy level in phosphorus? What is the highest energy level there? 3. Energy level 3. Now notice you have two places. You have some electrons in the S and some in the P, right? Which means, do you highlight both of them or just one of them? Both of them. Both of them are in those valence shells, or the valence electrons. So we have 2 in there and 3. So we add them together and we get a total valence electrons of what? 5. 2 plus 3 equals 5. So these are what we're going to use to draw it and check ourselves, okay? All right. So now we can get to our Bohr model. I've kind of already started it on your notes for you. But anyone figure out why there are 3 circles on your paper? Raul? 3 energy levels. So when you do a Bohr model, the first thing you do is look at the period number. Look how many energy levels is. That's how many shells we have. So we have 3 energy levels. So we're going to draw, that's the nucleus, 1 for the first energy level, another circle for the second energy level, and 3 for the third. That's the 3 shells, okay? There's our 3 shells. Now we're going to use our electron configuration to fill in our electrons. Now, in the first energy level, it can only hold a maximum of 2 because there's 1 orbital, so it can only fit 2. Just like boxes on your S, right? You only had 1 box for S every single time because there's 1 orbital. So we put our 2 electrons in there. They are going to pair because they have nowhere else to go, right? So we start at the top and we go 1 electron, and it gets a partner for 2. There's our 2 electrons in our first shell, our first energy level. Okay? Then, now that we know that is full, because we can only fit 2 in the first energy level, now we move to our second energy level, or second ring. And we look at our electron configuration and figure out how many electrons I have. I add these 2 exponents together. So 2 plus 6 gives me what? 8. So this is full again. But remember, we have 1 orbital for the S and 3 for the P, right? Just like we have our boxes. So we have 3 orbitals they can choose to go to. The way we represent that is we're going to use the 4 sides of our circle. So where this is going to be 1 orbital, second, third, and fourth. We start writing them separately because they hate being near each other. So we're going to add 1 there for our first electron. Our second electron is going to a different orbital at the top. Our third will go to another orbital over on the side, while our fourth will go to the bottom. Now that all 4 orbitals have 1, just like our boxes, now they can pair, okay? So then we're going to put the 5th one next to that one. We'll just go in clockwise order. 6, 7, and 8. This would be a full second shell. There are 8 in there. You can only fit 8, okay? Then we'll go to our third energy level, and we just calculated how many are in our highest valence shell, which is the outer shell. How many are there? 5. So we should have 5 in our last shell. So then we're going to start just like we did before. We're going to start on the left. We have 1 S's and 3 P orbitals in there. So we're going to do 5, but we're going to go 1, 2, 3, 4, and then we pair that last orbital with 5. This is the Bohr model of phosphorus. And the way you check it is the valence shell should be exactly the number of valence electrons you calculated. So we should have 5 there, and we have 5. Everything else on the inside should be full. Second is 8, that's full. And the first one has 2, which is full. Okay? Just like we do in our electron configuration, we just fill out. Okay? Questions? Okay. You're going to process those notes. Highlight anything that's important. Add any questions you need to ask me. Write a 3-sentence summary answering that question, and then put it into your notebook. Okay? Your notebook is going to be